And welcome back. I hope the rest helped. I hope you were able to take in some of these words and be able to make them your own and be able to put some of these definitions that we had from last video in your head. So here we go. We're going to do some examples now. All right, so the first part here says a dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. It reaches a height of s right here, reaches that height after t seconds. How high does the rock go? Ooh. All right, so this is where we have to think for a little bit. They give you S, that's your position. So let's go ahead and draw out what S would look like. Okay. All right, so I got S is 0 over 0. I'm going to have some type of parabola. Why do I know that? That's t, right? That's t squared. Okay, it's a negative parabola, so it's probably going to look something like this. All right. There's what my trajectory is going to look like. They want to know how high does it get? What's the highest position? And that's where we have to start thinking to ourselves, ooh, what can I tell from this graph? So you have to think about what is a rock doing? Okay, so a rock gets shot out. Whee! It goes up to the top, up to the top. And just as it's at the top, it kind of pauses because the velocity has stopped. And then I fall down. Okay? So right up here where the velocity has stopped. Velocity has stopped. Oh, my velocity. So how high does the rock go? Well, I know at that point my velocity is equal to 0. But how can I possibly find out velocity? And that's where we have to go back to what our rules were to begin with, right? Our rules were to begin with was that S prime of t was equal to my velocity. Okay? So let's go ahead and do that. Let's find our velocity. Our velocity, okay, our S prime of t, which is equal to our velocity, is going to equal 160t, that means just 160, minus 32t. Great. But now what am I going to find out here for my velocity? I want my velocity to be 0. So I make that happen. So I say that, well, okay, 0 is equal to 160 minus 32t. Divide by t, subtract 160, divide by negative 32. T should equal 5. Oh, so that means right here, t equals 5 is where it hits its highest point. I don't know what the highest point is yet, but I know its highest point is when time, okay, oh wait, is equal to 5. But how can I possibly find out what that highest point is? Okay. I don't know. I want how high does it go? What tells me height? Position. So I'm going to go find out S of 5. Okay. So what is S of 5? S of 5 is equal to, okay, 160 times 5 minus 16 times 5 squared, which is then equal to 800 minus 400. Is that right? 800, yep, minus 400. Okay, and that's going to equal 400. And what unit I am? Okay, feet. Okay, 400 feet. Boom. All right, so the next one says here, what is the velocity and speed of the rock? Okay, velocity and speed of the rock when it is 256 feet above the ground. Okay, well, I can find out velocity. Velocity, I have a function right here. Boom. Okay, then I can find speed. All right, speed, I gotta remember, is just the absolute value of velocity. I can do that too. But now it's asking me, but when it's 256 feet above the ground. So which one am I going to use? Which one tells me where I am above the ground? Oh, that would be the position function. So then I say, well, that means that I'm going to set my position function equal to 256, which is equal to 160 t minus 16 t squared. Okay. And what I'm going to notice right away on this one is that, hey, everything there is a multiple of 16. I'm going to divide everything by 16. I'm going to find out this is 16 is equal to 10t minus a t squared. And then I'm going to do some rearranging and set it equal to 0. 0 is equal to, let's see here, negative t squared plus a 10t minus a 16. Okay. So then I can factor out a negative everywhere. Negative, and this is just t squared, okay, minus a 10t plus a 16. And now I can factor out and say this is negative t plus 8. No, t minus 8. T minus 2. And so what does that tell me? That tells me that the rock is 256 feet around above the ground at t equals 8 seconds and t equals 2 seconds. Okay. So now I have to go, oh geez, that's kind of handy. All right. So I have to go find out now what my speed is. Okay, and my velocity. So first one is when it's on its way up. So on its way up, that's time equals 2. So v of 2 is equal to 160 minus 32 times 2. Okay, so 160 minus 64 is going to be equal to 96. And what's velocity measured in? Feet per second. Okay. And what is the speed? Well, my speed at t equals 2 is the exact same thing as the absolute value. So it's 96 feet per second. And then last on this one here, I'm going to say, well, now I need to find out what the velocity at 8, which is equal to 160 minus 32 times 8. And I have to see here 32 times 8, a negative 96 feet per second. Okay. Well, that's kind of handy. Makes sense too. All right. And then my speed, though, at t equals 2 is the absolute value. T equals 2, t equals 8 is the same, which is 96 feet per second. But let's take a moment, look at this. This negative 96 feet per second. Why is it negative? Why is it negative at t equals 8? After 8, what's happening over here? When t equals 8, I'm falling down. My rock is falling down. So this is actually telling me, hey, velocity is negative. That means I'm falling down. Over here, it's telling me my velocity is positive, so that's over here at 2. Hey, look, I'm going up. That's interesting too. All right. Okay. Part C is they want you to say, what is the acceleration of the rocket any time t during its flight? So you got to remember on this one, acceleration of t is equal to v prime of t. Okay, which is then equal to, well, v of t was these 160 minus 32t. So this one here is a negative 32. Okay, that's what my acceleration is. So my acceleration is constant. My acceleration is telling me that I'm always decelerating at 32 feet per second squared. Finally, part D. So part D is asking for, when does the rock hit the ground? When does the rock hit the ground? So this last part here is telling me, hey, when does it hit the ground? In other words, when is the position 0? So I can go ahead and say my position is 0, or S is equal to 0. And that's going to happen with 160t minus 16t squared. And that's going to tell me when my position is 0. Well, again, I can factor out. I'm able to say that this is equal to 16t times 10t. Okay. Nope, not 10t. 10 minus t. So what does that mean? That means that my when time is equal to 0, or time is equal to positive 10, that's when I'm at 0. That's when my position is at 0. So does it make sense that my position is 0 when time is 0? Yeah, that's when I'm getting shot out of a cannon. Boom. Does it make sense that they're at 10? Sure, there I am at 10. Okay, and it even is symmetrical, right? 2, 0. Okay, pretty nice. All right, so when do I hit the ground? At t equals 10 seconds. Boom. I know, long problem. It took us a lot of time. But here we go. That's a big problem. We won't go through another big one like that. Hopefully you guys got everything. It's a lot to take in. All right? Let's see if we can go a little bit faster on this next one. Okay, this next example, okay, here it says a particle is moving along a line, so its position at any time t is given by this what function? Again, position, where s is measured in meters and t is measured in seconds. Okay, so if you want to, always label this meters, and this is in seconds. Find the displacement of the particle during the first 2 seconds. So for part A, displacement for the first 2 seconds, I want to find s of t and subtract out s of 0, because that's where it went in, in those 2 seconds, and that's what displacement is. The displacement is the change in position over that time interval. Okay, so when I plug in s of 2 is equal to see here, 4 minus 8 plus a 3, and that becomes -1. And then I'm going to do s of 0 is equal to positive 3. And so now I have -1 minus a positive 3, which is equal to a -4. Okay. My displacement is a -4, okay, meters. Well, what does that mean? What that means is that, okay, again, remember I said positive means to the right, negative means left. That means that this went 4 units to the left. Okay, does not mean it traveled straight over there. Okay, it means that, hey, in those 2 time frames, in that snapshot from here to here, okay, displacement wise, boom, I just changed 4 units to the left. Okay, part B says find the average velocity of the particle during the first 4 seconds. Average velocity, again, average velocity from all those definitions we said, okay, was the change in s over the change in time. Okay, during the first 4 seconds. So that would be like saying s of 4 minus s of 0 all over 4 minus 0. S of 4 is 16 minus 16, okay, which is equal to 3 minus 3 over 4, which is equal to 0. Okay, so my average velocity for that time is 0. That was a big waste, right? You get all that work, you thought you're going to get an answer, it's really 0. Okay, does that make sense? So let's take a look at the graph. F of 4 in here, okay, S of 4, S of 0. What's my secant slope? Oh, it is 0. So it looks like my velocity, I didn't change anything, okay? But what they ask for next in part C is they say, I want my instantaneous velocity. So in part C, they want you to find v of 4. Well, how do I find v? V of t is just the derivative of s prime, like I had said. And so that's going to be 2t, okay, minus 4. V of 4 is then equal to 2 times 4, okay, 8 minus 4, which is equal to 4. And again, does that make sense? Does that slope? Yes, that looks like a positive force slope. Okay, and again, if it's meters seconds, that means it's meters per second. Okay, part D. Find the acceleration of the particle at time t equals 4. Well, again, for part D, acceleration is equal to v prime of t. I'm going to pause the video and I want you to see if you can find that out. Find v prime of t, find out what it is. Boom, there it is. Notice acceleration is just 2. Okay? Notice that acceleration at any time, doesn't matter what it is going to be 2. So it's always 2. Okay? Describe the motion of a particle at the values of t. At what values of t does the particle change directions? So for part E, let's take a look at the graph here. Okay? You have to realize that this one up here is my position graph. This one here is talking about my velocity. So all of a sudden here, my position graph, I'm moving away. I'm moving down. Okay, moving away, moving away, moving away, and now I'm moving towards something. I'm moving back towards something because I'm moving to the left, I'm moving to the left, getting to negative numbers. Now I'm moving back to the right, going towards positive numbers. Okay, so where did I change direction? Where did I change direction? I changed direction right here on my position graph. Notice what happened to my velocity graph. My velocity graph also tells me direction. When my velocity is negative, I'm moving to the left, just like I was moving to the left here. When my velocity is positive, I'm moving to the right, just like I started moving to the right there. Okay, so that's how I describe my motion. My motion, I change direction at 2. Okay, my directional change happens when velocity is 0, okay, or when my position function has a minimum or a maximum. All right, part F says use parametric graphing. We're not going to worry about parametric graphing. That's for BC people. Okay, let's keep going. I know, long run. I know. Bear with me. Here we go. Whew. Last one is we're going to take a look at how things change in general, if just general stuff about stuff you already know, but how do they look when I have a rate of change of something else. So it says here, write the volume of a cube as a function of the side length of S. Well, that's easy enough to do, right? Volume of a cube is equal to side cubed. Part B, they say find the instantaneous rate of change of volume with respect to x. Oh my God, volume with respect to s. Volume, so they want me to find the instantaneous rate. That means instantaneous rate. They want me to find the derivative with respect to s. Oh, I just used my power rule. It's 3s squared. Part C, they say evaluate the rate of change of v at s equals 1 and at s equals 5. So what they want me to say is they want me to say, here's my rate of change, and I'm going to evaluate it when s is equal to 1. All right? The big line there means evaluate. Evaluate. So then I go 3, 1 squared. Well, that's just equal to 3. Okay? What's my unit? My unit is inches cubed per inch. Okay? And I do the same thing here for dV ds is equal to 3 times, evaluated when s is equal to 5 squared, which is going to be equal to 75 inches cubed per inch. Okay? And again, what does this mean? This means when s is 5, my volume, if you can picture the sides of a cube generally expanding, just growing, okay, just like growing bigger and bigger and bigger, my sides of my cube, okay, my volume is increasing at 75 inches cubed per inch. Okay? Here we go. Part D, they ask you what is it measured in. I've already answered that question. Again, you cannot cancel stuff out. It's not going to be inches squared. All right? Last but not least, one for you. I want you to figure this one out. I'll give you time to read it, take a look at it. I want you to figure it out and answer the questions. Finally, your homework. I understand this was a long one, okay? I'm going to give you guys a couple of days to get the homework done. I understand. Thank you for bearing with me. Here's your homework. Have a great day.